Hello, my name is Claire Steffen, and I chose the first task for my geometry screencast. This is an investigation into the conjectures about a midpoint quadrilateral. I believe that it addresses these two Common Core standards. You draw points, lines, and line segments. You address perpendicular and parallel lines and should be able to identify the two-dimensional figures that it creates. Should also be able to classify the two-dimensional figures based on the presence or absence of parallel or perpendicular lines. For this activity, I use these two definitions just because I know that definitions of shapes can vary from class to class. So I used that a quadrilateral has four sides. It's two-dimensional, closed, so each of those sides touch each other, and these sides are straight. A parallelogram has opposite sides parallel and equal in length. Both of these definitions I got from the mathisfun.com website. So with that, we'll move into GeoGebra. I like to use Classic, and the first thing that I like to do is get rid of these grid lines. I like to just be able to have clear space to build whatever quadrilateral I please. So I'm going to come up and expand to the right and expand this menu. I'm going to click on the grid lines, and I'm just going to select white space. Now there's no more grid lines. Another thing that I like to do is click on that gear, click on the gear again, and then labeling. I only want my new points to be labeled. I don't want to be encumbered by the segment names popping up in there. And with that, I will begin constructing the quadrilateral. And so first I'm going to do 4 points by selecting the point tool up at the left and just slap 4 things on there. Boom. Then I'm going to come back up to the left and select the polygon tool, and I will connect all 4 of these lines. The next thing that we need to do, since this is we're investigating the midpoint quadrilateral, is we need to get the midpoint of each of these lines. Luckily, GeoGebra has a tool for that. So if we come back up to the left, where it says point A, and then we'll select the midpoint or center. And then we can just tap on each of these lines, and find the midpoint. And it doesn't matter where you click, it'll find the midpoint of that line. And we'll create the quadrilateral that's formed by these 4 points. And again, this is a quadrilateral because it's closed with straight sides, 4 of those sides to be precise. Now, I find it kind of difficult to distinguish in between these two quadrilaterals, so I'm actually going to be changing the color of this center one. I'm going to come over here to the left, select Q2, those 3 dots next to it, click Settings. Come over to Color. I like this nice blue for it, and I'll make it a little less see-through, just so it really pops. Now, you want to be sure that you're on the Move tool before you move on to your next step. And in this step, we're going to be dragging and experimenting with this polygon, this quadrilateral. You can do this by dragging by points, either in or out, or maybe in a little circle. I like the circle because it can show you what a consistent movement will how a consistent movement will affect the shape. But you can also drag by the sides, in and out and up and down. So the first thing that I'm noticing about the shape created is that it's a parallelogram. These sides the opposite sides are congruent and parallel. Something else that I can see is that it seems that this inner quadrilateral will be half of the area of the parent quadrilateral. Now, as for a third conjecture, we can come around in here and, well, this shape looks like a rectangle. So my last conjecture is that when opposite points of the parent quadrilateral are lined up, the figure formed in the center is a rectangle. But I'm more interested in my first conjecture of that these are, the figure formed as a parallelogram. So to investigate this, I'm going to hide the parent quadrilateral. And to do this, I'm going to come back over to the left. See this little circle right here to the left? You just click on it, and there it's gone. I'm going to hide these points as well, just to be totally clean. Now, one of the biggest things about parallelograms is the two parallel sides. So we're going to use the parallel line tool, come back up to the top left, and select parallel line. We're going to click on this line segment, and then boom, we've got a parallel line. We'll do that again for the other sides, and then we can just drag these. Again, make sure you have move selected before you go play. So we can see that this is, we made this line so that it is parallel to this one. It's also parallel to its opposite line. So the same applies for the top and bottom sides. They're parallel. But this is only one of the characteristics of a parallelogram. Yeah, it's got two parallel sides, but are they congruent? To do this, we can come back to our parallelogram, and we can select these segments over here. We click on the three dots, click Settings. We can select Show Label, and then the value. And then you can just click on the line and do the same thing for all of them, because it keeps this settings screen open to the right. Sweet. So now we can see that the shape created has two sets of congruent parallel lines. Let's go ahead and re-show all of our original parallelogram, and then we can move it around as well to verify that this does hold. And you can see that these parallel lines are moving because they are constructed based on the segments. So you can always see that no matter where I move it, we move it right here, these two lines are still parallel. And the same goes for these two lines. And these values show us that they are indeed still congruent.